So even though exercise 414 is a bit long and tedious, it's still quite good to use as kind of a checkup, that you know all the definitions. And what we'll do now is solve E and F. And what we need here are the definitions for covariance and correlation. That's what this letter stands for, the row, it stands for correlation. So let's just get started here. The definition of the covariance between N1 and N2 tells us that this is equal to the mean value of N1 multiplied by N2 minus the mean value of N1 multiplied by the mean value of N2. So had N1 and N2 been independent, the covariance would have been 0, since then these two would have split the expected value up into mean of one multiplied by mean of the other, and these two terms would have cancelled. However, N1 and N2 are not independent, so we will have to calculate the covariance by calculating the mean of N1 multiplied by N2. Now, after we have found the covariance, we will need to find the correlation. And the correlation of N1 and N2 is defined as the covariance of N1 and N2 divided by the square root of the variance of N1 multiplied by the variance of N2. But however, remember, N1 and N2 have the same distributions. That means they have the same variance. So that means what I have down here is essentially variance of N1 squared, and then I take the square root of it. So this is just equal to the covariance of N1 and N2 divided by the square root of the square of the variance of N1, which is just the variance of N1. So in this exercise, before I can find the covariance and the correlation, I need to find the mean value of N1 multiplied by N2. So that is given as N1 multiplied by, and so that is given as 1 multiplied by 1 multiplied by the probability that N1 is equal to 1 and N2 is equal to 1. Sorry, this is not going that well. Plus the probability that N1 is equal to 1 and N2 is equal to 2, and then that value would be 1 multiplied by 2. Probability that N1 is equal to 1 and N2 is equal to 2. Plus the probability that N1 is equal to 2 and N2 is equal to 2. And then I would have to multiply 1 here. Plus, that N2 is equal to 1 here. And then plus the probability that N1 is equal to 2 and N2 is equal to 2. Multiplied by 2, multiplied by 2. So this is the mean of N1 multiplied by N2. Because there are two stochastic variables here, I need to use their joint distribution. This is probably one of the main points of this part of the exercise. So the next thing that we need to do is to find the variance of N1. And in order to find the variance of N1, let us just recall that the variance is equal to the mean of N1 squared minus the square of the mean of N1. And we already know the mean of N1, so this term is already known. However, we need to find this term. And in order to calculate the moment, we need 1 squared multiplied by the probability that N1 is equal to 1 plus 2 squared multiplied by the probability that N1 is equal to 2. Notice that both in the case of the mean of n1 times n2 and in the case of the mean of n1 squared, I do not take in any of the terms where n1 or n2 can be equal to 0, because as soon as I multiply the value 0 onto one of those terms, that term would cancel. So would vanish. So here I have the calculations that are needed in order to finish problem 414, E and F. So let's just take a look at how that is implemented, in Excel. I find the mean of n1 multiplied by n2, and I do it exactly as we describe it in the formula here. So it is 1 multiplied by 1, and then I multiply by the probability of both n1 and n2 being 1. And then we have 1 multiplied by 2 multiplied by this probability plus the other combination of 1 and 2 multiplied by this probability for the other combination plus the probability that both n1 and n2 are equal to 2 and multiplied by that value, 2 multiplied 2. So that gives us 0.085, and when we take that value here and then we remove the mean of n1, which is this, and multiply by the mean of n2, which is also this because they have the same distribution, then we get 0.06098. So that was the covariance. Now in order to find the variance, we established that we need to find the second moment of n1. So that is exactly what we do here. We take 1 squared multiplied by the probability of n1 being 1, and add 2 squared multiplied by the probability that multiplied by the probability that n1 is equal to 2. Then the variance is given as this second moment minus the square of the first moment. Then the correlation is given as in our formula as the covariance divided by the variance of n1. So that was the covariance and the correlation. If everything kind of went a bit too quick for you, just go back and take a look again. These calculations are both tedious and rather confusing, but at least after you've done these calculations, you can be sure that you can remember the definitions for covariance and correlation. Oh yes, just one note before we end. The only reason why I can replace the variance of n2 with variance of n1 is because they have the same distribution in this exercise. This is not something that is true in general, it's something that is specific for this exercise.